Hey, what's up, class? Welcome back. Another episode of Math 1 Distance Learning. So we are coming to the end of this unit. We've been working on equations, inequalities, and proportions. And now we are at the end of the unit, and I'm going to go over the study guide with you. So I'm going to walk you through it. You need to have everything copied down to get full credit. Okay, so you should have that worksheet in front of you. And here we go. I'm going to flip over to the DocuCam. All right, so test number 3, study guide, equations, inequalities, and proportions. If you are watching this right now on distance learning, we are not covering this thing called literal equations. So normally in a normal traditional school year, we would also cover this and you would have questions on your test. At the end of the study guide today, I am going to go over this, but this will be for future years when I want to share this video with my students. But for you that are on distance learning in the year 2020, today is December 4th, so you will not have any of these questions on your upcoming test, okay? All right, so here we go. So solving equations. We've learned solving equations that there are 3 different ways that we can answer an equation. Remember, solving an equation means we're trying to find the solution for the missing variable, for the x or the y or the z. So we've learned that you could have a one solution answer. So a one solution answer would be an example like this. This is a real simple problem. I'm going to solve for x, so I want to subtract 10 on both sides, and the answer is 7. So the only answer that could fit right there, the only value is positive 7. 7 plus 10 makes 17. Okay, so this is a one solution. This is a one-trick pony, one solution for that value right there, only one solution. Okay, but we have learned that sometimes when you're solving, sometimes you will have what's called a no solution answer. There actually are no solutions that work. So here would be an example. Let's say we've got the problem 2x plus 3 is equal to 2x minus 4. So the first thing that we would probably want to do is subtract 2x on both sides. So that gets canceled, and we are left with 3 and negative 4. Well, we know that this is not a true statement. 3 is not equal to negative 4. And since that is false, and our variable has been canceled out, this has already been canceled out, this one's been canceled out. So since we have no variable, we would say there are no solutions for x because we got a false statement. This is false, it's not true. So if you get a not true, then there's no solutions. Now we've also learned that there is a third possibility, which is called infinite solutions. Okay, or another way to say it is all real numbers. So infinite, remember like Buzz Lightyear in Toy Story, he'd say to infinity and beyond. Okay, so let's look at this example here. So we have 3x plus 5 is equal to 3x plus 5. So this side is exactly identical to that side. So let's see what happens. If I subtract 3x, I subtract 3x, I'm going to be left with 5 is equal to 5. Well, this side is equal to that side. That is true. And since our variable has been eliminated, we say infinite solutions for x. Infinite solutions for x. Or we could also say x is equal to all real numbers. X is equal to all real numbers. Okay? Now, before we move on from solving equations, there are a couple of tips that I have over here. So we want to remember when you're solving an equation, we want to remember to organize and combine like terms on each side of the equation. So you want to organize and combine your like terms on each side of the equation. before you start any inverse operations. Okay, so what in the world am I talking about? So here's an example. Let's say we've got a problem that looks like this right here. So we've got 2x minus 3 is equal to 5x plus 1 minus x. Well, some of you might look at this and you might go, oh, okay, well, I'm going to subtract 2x. There's this 5 here, so I'm going to subtract 2x. But you're going to run into some trouble. We need to get this side organized over here before we start the actual problem. So we need to combine those. We need to combine like terms. So 5x minus an x is going to be equal to 4x plus 1. And then you would continue with the problem. So I'm not going to, oh, let's see, I did go a little bit further. Then we would solve the problem. So we would subtract 2x. Now I'm going to subtract 2x. Instead of doing it originally, I want to do it now. And then that's going to, these cancel. It's going to give me negative 3. I get 2x plus 1. And then I would subtract 1 from both sides. And I'm going to get negative 4, right? Negative 1, negative 3 is negative 4 is equal to 2x divided by 2. And x is equal to negative 2. Okay, but what I wanted to show you, what I wanted to focus on in this particular problem is this step back here. You want to make sure that you combine before you just start solving. You don't want to start adding or subtracting to both sides until you combine. Okay, all right, so that's solving equations. Next page. Okay, so now we are on solving, where are we? Solving inequalities. Okay, so when we're solving inequalities, a few things to remember. We want to just use the normal rules for solving equations. We're going to follow the same rules. Okay, it's like, what would be an example? It'd be like baseball and softball, right? They're not the same game, but a lot of the rules are the same. So we're going to follow the same rules. Okay, so the basic same rules. There's a few rules that are slightly different. Okay, but when we're solving inequalities, we want to follow the same rules for equations. Okay, so here would be a basic inequality. So I want to, even though this is a greater than, I'm going to follow the rules of equations. I'm going to subtract 3 from both sides. I'm going to get 5x is greater than 20. And then I'm going to divide both sides by 5. I want to isolate my variable. And we get x is greater than 4. Okay. All right. Let's see. Graphing your solutions. Let's talk about graphing your solutions. Okay. So remember, we want to use a shaded circle. A shaded circle when the inequality symbol includes the equal sign. For example, up here, there's no equal sign, right? So we want to use a shaded circle when there is an equal sign. This means the boundary point is included. The boundary point's included. So if there's an equal sign, we want to shade our circle. Okay, so here's be an example. Here we've got the equal sign, so we want to shade our circle. Remember, we want to draw that arrow going that direction. And the reason we know we can trust that is our variables over here on the left side. So if I was going to graph this, it would look something like that. So this 4 is included in the solution, right? It's 4 and everything less than 4. Okay. All right, and then let's go back up to the top of the page over here on the right side. Remember to flip your inequality symbol when you divide or multiply. When you divide or multiply by a negative number. Okay, so I spent a lot of time talking about this when we were going over example problems throughout the semester. So this number right now is a positive number. But as soon as I divide by negative 4, now I'm changing this thing to a negative number. And if I'm going from positive to negative, I have to reverse my symbol. Or if I was going from a negative to a positive, if I change the sign on the answer, on the constant, then I've got to reverse my symbol. Okay, so I'm going to divide by -4, so I have to reverse my symbol. So 24 divided by 4 is -6. So originally my arrow was pointing that direction. Now we want it to point that direction. Okay. All right, and then on shading, so we did on graphing, I'm sorry, we did the shaded circle, and then I kind of went out of order here. Let's go over here. We want to use an open circle when there is no equal sign, right? No equal sign. Okay, open circle. All right, this means the boundary point is not included in the solution. All right, so here would be an example. X is greater than 2, so we want to draw that that graph going to the right, and we want something that looks like that right there. Open circle, boundary point is on 2, open circle going to the right. We want everything bigger than 2, bigger than 2. Okay. All right. Next up, we've got solving compound inequalities. Solving compound inequalities. So a compound inequality, remember, that's where we have 2 inequalities. So if it's an and problem, then the graph is going to go in, right? Like the letter N is in the middle. So that if it's an and problem, the graph's going to go in. The graph will go in, right? In. Okay. So here's an and problem. So this is a boundary at -2, and this is a boundary at 3. They're both shaded. So it would look like that. A boundary at -2 and a boundary at 3. We want everything in the middle. Okay. Now, let's see. Oh, we'll get to the remember to look for in a moment. But here, another way that you will see on your test, another way to write this here is to put X in the middle. And I actually like this easier because we know that there's a boundary at -2 and we know there's a boundary at +3. And then we just put the X in the middle and make sure you draw both of your street signs pointing to the left. So a boundary at -2, a boundary at 3. -2 and 3. Okay. All right, let's go, before we get to the remember, let's go look at the OR problems. Come on. All right, so for the OR problems, if the inequality is an OR, remember O, that tells us that the graph is going to go out. O and O, the graph's going to go out. Okay, OR problems go out. So here's an example. This is a boundary at -2. We want one graph going that way. And this is a boundary at 3. And we want the other graph going that way. Okay. So they're going to go out away from each other. This one has no equal sign. So it's an open circle. This one has the equal sign. So it's a shaded circle going to the right. All right. And then my little note down here at the bottom. I'll let you copy that for a second. All right, you can pause the video. Remember, you can pause the video. Okay, my note down here. Remember to look for the Roadrunner trick. Remember the Roadrunner trick that we talked about. That's when the variable is on the wrong side, right? So for example, if the variable's over here, that Roadrunner came by, he's trying to trick you, right? The Roadrunner came by, he's trying to trick you. He flipped the sign the wrong way. So we do not want to draw our graph going that way. It's pointing the wrong direction. So we have to remember, we have to move our variable over to here, move this to this side, and then flip that around. So really what we want is this right here. So we really want a graph that's going to go that direction. Okay? All right, so just remember to look for the Roadrunner trick. It's when the variable is on the wrong side. It's over here. It's got to be on this side. This is where we want it. All right, last page of notes. Got that, the Roadrunner trick. Okay, solving proportions. Okay, when we're solving proportions, I taught you two strategies. One strategy, I call it the leapfrog strategy. Okay, so in the leapfrog strategy, we're trying to figure out, so here's a proportion. We have 3/8, and it's equal to some number over 16. So if you're leapfrogging, you want to look at the bottom or the top, whichever one has the two numbers, and I want to figure out how am I going to go from this number to this number. And remember, you have to either multiply or divide. You can't add or subtract. So we can't go 8 plus 8. We're not adding, we're multiplying or dividing. So in this case, we're going to leapfrog times 2. So up here, I would leapfrog times 2. So 8 times 2 is 16. 3 times 2 is 6. Okay, 3 times 2 is 6. Okay. All right. The other strategy that I taught you was the cross multiply strategy. Okay. So this was the leapfrog. Now here's the cross multiply. And the cross multiply, this is where you have problems that are a little bit more complicated, a little more sophisticated. So here, I can't really leapfrog, right? I can't go 4 times a number makes 10. There is no whole number. And even if there was, this is really messy. So we have to cross multiply. We have to go this times this and this times this. So I'm going to do that. So I'm going to go this way. It doesn't matter. You could start here and go down first, or you can go this way. So I'm going to go 10 times y plus 2. 10 times y plus 2. And then I'm going to go 4 times 5y. 4 times 5y. So I got to do a boom chicka boom here. Okay, so 10 times y, 10 times 2, and then 4 times 5y. It's going to look like that right there. Okay, and now I'm going to just solve the problem. So I've got 10y over here, 10 yogurts here, and I got 20 yogurts here. So the next thing I want to do is subtract 10y from both sides. These are going to cancel. And I'm going to get 20 is equal to 20 minus 10. So that's going to be 10y down there. And I get 20 is equal to 10y. I'm going to divide by 10. Boom, those are canceled out. 20 divided by 10 is 2. So my answer way back up here in this original problem, way up here, my answer is y is equal to 2. If I go 5 times 2, 5 times 2 is 10. 10 over 10 is the same as 2 plus 2, 4 over 4. So my answer is 2. Okay. All right, a little bit more about solving proportions. When we're solving proportions that are dealing with word problems, we want to identify and label the two categories. So I've given you several examples in classwork and homework where in the word problems, you want to come up with what are your categories. So for example, the categories that are being compared, right? So for example, determine whether the missing number goes upstairs or downstairs. Okay, so if I'm comparing apples to oranges, okay, apples to oranges, then the way I would want to do this, so let's say there's a ratio of 3 to 5. So I'm comparing apples to oranges, and it's a ratio of 3 to 5. So the way I would do this, nope, here's the rest of the problem. There are 600 apples, so how many oranges? Okay, so I'm doing apples to oranges. There's a ratio of 3 to 5, and there are 600 apples. We want to figure out how many oranges. So the way I would do this is I would set up my categories. So my categories are apples and oranges. We already know that there's a ratio of 3 to 5. So 3 apples for every 5 oranges, 3 to 5. So I'm going to put that ratio right there. Now it tells us that there are 600 apples. So that would be in the upstairs. The apples go upstairs. And then our missing value is we're trying to figure out how many oranges. That would be downstairs. Now, we could leapfrog this. We could do 3 times a number makes 600. 5 times that number makes something. Or you could cross multiply. You could do 3 times x and 5 times 600. Okay, so I'm not going to solve the rest of the problem. I'm just trying to show you how to set up these word problems. So make sure you figure out what are your categories that are being compared, and then figure out where your missing number goes. Does it go upstairs or downstairs? And in this case, our missing number went downstairs, down here. Okay. All right. So if you are on distance learning in December 2020, you are done with this study guide. You can copy the rest if you'd like. Maybe I'll give you a couple bonus points. If you are watching this and it's not December 2020, if this is in the future, then you are going to have to do the 4th part down below, the solving literal equations. Okay, so let's go through that really quickly, and then we'll be done for today's lesson. Okay, so part 4, solving literal equations. These are variable formulas. Okay, so if we're on distance learning, we haven't even talked about these. Okay, so use the general rules for solving equations, right? Just your basic rules. But you want to identify who the star of the show is. So who are you solving for? Who do we want the spotlight on? Okay, and then you want to isolate that variable. So whoever the star is, that's who you want to isolate. All right, so I gave you an example here. So here's your equation. A is equal to B over C. So A is equal to B over C. But we want to solve for B. We want B to be the star of the show. Okay, so we want B to be the star of the show. Right now, A is the star. A is by himself. But we want to rearrange this equation so that B is all by himself. All right, so how do we do that? Well, the first thing that we need to do is get rid of this downstairs Danny. We need to get rid of that right there. Okay, so the way we would do that is we'd multiply over here by C and multiply there by C. So I'm going to do it so it looks just like that right there. So these get canceled out, boom, boom. And then over here, I have C times A. So these get canceled. C times A is equal to B. C times A is equal to B. And then I could flip it around and have B equal to A times C, right? A times C. So the question said to solve for B, make B the star of the show. And I just did that right there. Now he's by himself. Okay, so it's that simple. You just follow the general rules for equations, but instead of using numbers, everything is a variable. Okay, all right, that's all we've got for you. Study hard. Okay, so we've been practicing these problems. If you study that study guide, I gave you several examples there. If you study your practice test, that's really important. And then look at some of your homework and some of your other assignments, right? Cover the problem, cover the answers up, try and solve it, check to see if you did it correctly, and you should do great. Okay? All right, I will see you guys next class. We'll talk to you later. Bye.